from the Harvard Collection of Historical Scientific Instruments. She is a historian, and she has the great joy of curating and taking care of old instruments at Harvard. And so today she's going to be talking about politics and the dimensions of the solar system. John Winthrop's observations of the transit of Venus. Thank you. Let me just figure out how this works. Which is the forward button? Not that one. The forward button is towards the right, which I was thinking would be like facing forward. But, okay, thank you. In May 1761, John Winthrop packed up 2 young gentlemen, an excellent clock, Hadley's octant, a refracting telescope, and a nice reflecting telescope adjusted by crosshairs, and embarked for Newfoundland to observe the transit of Venus. So we went from Boston all the way up to there, the easternmost point of North America. Now, Winthrop's departure was hasty. Only days before had the president and fellows of Harvard College approved Professor Winthrop's request to take the college apparatus behind enemy lines to serve the cause of science. Winthrop knew he had no time to waste if he were to reach Newfoundland and properly calibrate his equipment before the transit. Winthrop's expedition to St. John's, Newfoundland was nothing short of remarkable. His goal was to help determine the distance from the Earth to the Sun, and he was the only North American astronomer fit for this project at that time. So I know most people here know what the transit of Venus is, but just to review it in case there is someone here who doesn't, and to understand why it was so important to Winthrop. Now, transits of Venus are rare astronomical alignments in which the planet Venus crosses the face of the Sun as seen from the Earth. And I just figured out this is the laser pointer, so Venus would make a little, the spot would make a little path across the Sun. And these transits occur in pairs, 8 years apart, and the pairs are separated by intervals of 105.5 or 121.5 years. In November 1639, Jeremiah Horrocks and his friend William Crabtree were the first to witness a transit of Venus. Unfortunately, Horrocks died just over a year later at the age of 21, and Crabtree did not long outlive him. So not much could be made of their observations until published posthumously in 1662. And here you see some of those notes. Now, indeed, few knew that they had even attempted these observations, for as Horrocks explained, in her quote, "I hope to be excused for not informing other of my friends of the expected phenomenon, but most of them care little for astronomical trifles of this kind, preferring rather their hawks and hounds, to say no worse." Now, one person who did care about such things was the celebrated astronomer and Royal Society fellow Edmund Halley. Now, he called the transit of Venus, quote, "that sight which is by far the noblest astronomy affords," unquote. In a paper published in 1717, Halley explained how simultaneous observations of a transit from far-flung places around the globe could be used to calculate the distance from the Earth to the Sun. He urged astronomers to collaborate in order to determine the dimensions of the solar system, one of the great unsolved problems of the day. Now, in response to Halley, astronomers sailed to remote parts of the world in order to observe the next transits in 1761 and 1769. In 1761, the Royal Society organized expeditions to St. Helena and Sumatra, and the French set off for Siberia, Vienna, the island of Rodriguez in the Indian Ocean, and Pondicherry. Such expeditions were supported by royal warrants and letters of safe passage in order to ensure the safety of the enterprise in the midst of the 7 Years' War. In this, the greatest monarchs of Europe were agreed: science should rise above international politics. Of course, there was no guarantee that enemy ships would hold their fire until they got close enough to read these writs. In fact, Charles Mason and Jeremiah Dixon, the same fellows after whom we named the Mason-Dixon line for their survey of that line, Mason and Dixon were on their way to observe the transit in Sumatra when, just out of Portsmouth, England, their ship, the HMS Seahorse, was bombarded by a French frigate. 11 sailors were killed, 37 wounded, and the ship just limped back into port. Well, Mason and Dixon were terrified, and they informed the Royal Society that they would go no further, the consequence be what it will. Well, the Royal Society demanded that they proceed, lest their refusal disgrace the nation, dishonor the Royal Society, and lead to their prosecution and utter ruin. Mason and Dixon reconsidered and set sail without further delay. Ended up probably figuring it's safer to be on the high seas than in London, where the Royal Society could get them. But when Sumatra fell to the French, they were not able to reach their destination, but were permitted to watch the transit from the Cape of Good Hope. Now, whether the monarchs lent their support, as claimed, in order to cultivate the arts and sciences, those great ornaments of civil society, or as one suspects, in order to support astronomy because of its presumed use to navigation, and consequently its impact on the commerce and wealth of their kingdoms, the fact is that they promoted the largest international scientific endeavor ever attempted to that date. Despite many mishaps, the transit of 1761 was observed by astronomers at some 70 stations around the world. The fact that the transits of Venus were so rare made the approaching spectacle a topic of conversation among persons of every rank, of every profession, of every taste. Drinking songs, poems, and satirical pictures about the transit were circulated in the 18th century. And here you can see we're not really, while the lady is looking at the transit, the guy seems to be ogling someone over to the right there. Hundreds gathered in the streets of major cities like London to observe the event through smoked glasses. Now, back in Cambridge, the Hall is professor of mathematics and natural philosophy, and the most qualified astronomer in North America in 1761 was John Winthrop. Winthrop was eager to enlist in a transit expedition, and the value of the expedition was very clear to him. So in 1761, Winthrop realized he would be the only observer in North America and the most Western observer internationally. But as late as April, it was not obvious that he would get support for an expedition. He was situated in what one London magazine derided as, quote, unquote, an infant seminary, and he had no personal resources upon which to draw. So he turned to his former student, James Bowdoin, who had become a very wealthy merchant, an influential political leader, and a friend. Now, Bowdoin was interested in science. He corresponded with Benjamin Franklin, among others. And as a member of the Council of the General Court of the Province of Massachusetts Bay, this is a long title, but that basically is the legislative body of the Massachusetts Bay Colony. It's always referred to technically as the General Court. And the council is the upper chamber, and the House of Representatives lower chamber. So I'll be using those terms a bit. So Bode is a member of the council, and so he takes a letter from Winthrop to Francis Bernard, the royal governor of the province. And the governor makes a very strong case to the House of Representatives, which I won't read here, but the upshot is this. He says, you know, the Massachusetts House of Representatives should not be outdone by the kings of France and England, and therefore should issue orders for Winthrop to sail at the colony's expense to Newfoundland. And upon his return, Winthrop would be compensated with £30, which was worth nearly half a year's salary. So they put their money behind this. With the backing of the governor, the council, and the General Assembly of Massachusetts, it would be hard for the president and fellows of Harvard College to say no to the plan. President Edward Holyoke had a long-standing interest in astronomy and likely supported the expedition when it came up for a vote on May 5th, 1761. But Winthrop wanted to take Harvard's finest and newest instruments. They would be at some risk. For example, the French and British had been fighting over territories held in Canada and Upper New England since 1754 in what was known as the French and Indian War. Still, both sides agreed, at least on the administrative level, that the cause of science really should rise above international conflict. Governor Bernard had given Winthrop letters directed to His Majesty's officers, commanders, and other of his subjects, and likewise to those of the French king, as were proper, he said, to facilitate the execution of the enterprise and to secure it from disappointment by the enemy. That's the quote. On top of these letters of safe passage, Harvard required Winthrop to see to it that all such instruments shall be insured, so that the college may not suffer by the loss of any of them or any damage that could happen to them on this voyage. And here you see the page in the photocopied of the documents that support this meeting, 1761. Now, Winthrop agreed to this condition, satisfied that care would be taken. The Harvard Corporation voted to allow the professor and apparatus to be employed in this affair. On May 5th, a spring day during which it snowed, John Winthrop got the good word. On May 8th, he recorded his last full readings in his meteorological journal in Cambridge, and on May 9th, he embarked from Boston with 2 students on board the sloop chartered by the General Assembly. He arrived in St. John's, Newfoundland on May 22nd. He observed the transit of Venus on June 6th and stayed on to make further observations. Now you can see there's a very tight timeline here. As those of you who've gone on eclipse expeditions or gone to see the transit in 2004 somewhere know when you have to go and set up your apparatus. He did not return to Cambridge until about July 25th, beginning his full meteorological records the following day. So, what did he do and why did he stay so long after the event? Now, according to Harvard records, Winthrop took, here's the Newfoundland and some of the instruments he took. He took, quote, the timepiece, a small refracting telescope given by C. Kilby, Esquire, the reflecting telescope lately given by the Honorable Thomas Hancock, Esquire, and Hadley's octant given by Ezekiel Goldthwaite, Esquire, unquote. We'll say a little more about these. But we might want to question why this reference to all these donors, and whether these instruments were chosen because they were the best that Harvard had for the purpose, or whether some of them might have been chosen just as to give credit to the benefactors who had supplied them. Now, in St. John's, Newfoundland, Winthrop and his students set up their observatory on a hill some distance from the town where the rising sun could be seen. Winthrop had brought a pendulum clock made by Thomas Tompion of London around 1675. The clock was no match for astronomical regulators that could be had in London in 1761, but it was the best that Winthrop could get. Still, even though it was 100 years old, it was a incredibly precise timepiece, having a bolt and shutter device to maintain power while the clock was wound and so forth. Now, at St. John's, the clock was secured to a pillar set into the ground under a tent, and you can still see some of the screw holes back here from that event. And it was regulated by means of equal altitudes of the sun, observed by a gnomon and a reflecting telescope. This foot-long telescope was made by Benjamin Martin of London around 1760 and had been presented to Harvard in April 1761 by Thomas Hancock, the uncle of John Hancock, the political leader and famous signer of the Declaration of Independence. And here you see the inscription right on it, the gift of the Honorable Thomas Hancock, so forth. So you can see this is just in time. April it arrives, and right before the transit, presumably intended for it. Winthrop and his students adjusted the clock and verified the meridian several times a day. Winthrop reported, quote, "With an assiduity which the infinite swarms of insects that were in possession of the hill were not able to abate, though they persecuted us severely and without intermission, both by day and by night, with their venomous stings." The Martin telescope and Tompion clock were also the principal instruments used during the actual transit, a day described as serene and calm. According to Winthrop, the sun rose behind a cloud that lay along the horizon but soon got above it. And at 4 hours, 18 minutes, we had the high satisfaction of seeing that most agreeable sight, Venus on the sun. Now, the spectators were awed, and they included Captain Ross, commander of His Majesty's garrison, and Michael Gill, Esquire, chief judge in the courts. I think we should get some of these folks to come to Stellafane next summer. To lend more grandeur to our proceedings here. But as Winthrop observed the progress of Venus and the sun by means of these cross wires in the reflecting telescope, one assistant, i.e. one of his students, counted the clock while the other recorded the times that the preceding limbs of Venus and the sun touched the vertical wires and the lower limbs were the horizontal wires. The small refractor rod was used for little more than showing off Venus during her transit to the gentlemen of the place who gathered to behold the spectacle. It also might have been brought along as a backup to the reflector, and out of respect for the donor, Christopher Kilby, Esquire, who had been the chief agent of England for Nova Scotia. And what about the Hadley's quadrant, given by Ezekiel Goldthwaite in 1760? If it were half as nice as the one he bought to replace its loss in 1764, one we see here, it was an exquisite instrument indeed. And though it was given a place of honor at the start of all reports of the transit, it was never mentioned again. Presumably it was used to determine the latitude of the site, which Winthrop found to be 47 degrees and 32 minutes north, in disagreement with that down in books and maps. It was also the right tool for finding longitude by means of lunar distances, but Winthrop preferred to use the telescope to observe lunar occultations and Jupiter satellites for this purpose. Alas, the circumstances were unfavorable for both for 7 weeks. So in despair, Winthrop attempted to measure the moon's right ascension. And although he reported the longitude he had found in a pamphlet he published on his return, it was 50 degrees and 14 minutes by him, Winthrop confessed in his report to the Royal Society that he had botched this crucial measurement. He wrote, "The only observation I could get to find the longitude was of the right ascension of the moon, which I endeavored to find by comparing with that of a fixed star. But whether any mistake was committed in counting the clock, or in writing down the observations, or whether the position of the telescope was disturbed by any accident in the interval between the moons and stars passing, I am not able now to say." How embarrassing. Now, Winthrop's expedition in Newfoundland lasted 11 weeks, and on his return was celebrated in the local papers. He published a report in this pamphlet, a relation of the voyage in Boston, and another in the Philosophical Transactions of the Royal Society. His data, when combined with that of Mason and Dixon at the Cape of Good Hope, gave a parallax of the sun equal to 8.42 arc seconds. This was close to the mean value, 8.56, computed by James Short. The expedition is immortalized in a famous portrait of Winthrop painted by John Singleton Copley. Items in the portrait include his diagram of Venus on the Sun in 1761. He's holding that in his hand. Venus's Hill, the St. John site where he made his observations. And the telescope on the table is the one he used to observe a transit in 1769, but more on that later. But by and large, Winthrop and others were not satisfied with the results from 1761. Many observers were clouded out and could not reach their intended destinations because of the war. And those who enjoyed the sight of Venus crossing the sun worried that their timing of the planet's contact with the sun's limb was distorted by the notorious black drop effect, the dark tongue that seemed to leak from the disk of Venus to the sun's edge just before contact. Fortunately, nature offered another opportunity 8 years later, in 1769. Planning began immediately, because astronomers knew that if they failed in 1769, the next transit would not come for more than 105 years. The Royal Society organized several expeditions for the transit of 1769. But while the fellows had their heads in the clouds, the Society's clerk ran off with all their money, £1,500, a scandal that they covered up when they applied to the king for assistance. A very famous expedition, though, did come out of this support of the Royal Society. They sent Captain Cook to Tahiti, and here you see Cook and the site of where he observed the transit. But what about our friend John Winthrop back at that infant seminary outside of Boston? Well, here's a scene of the Boston landscape in the 1760s, and back in colonial Boston, the political landscape was much altered by 1769 when Winthrop considered organizing a second expedition to observe the transit of Venus. In 1761, the enemy had been the French, and he had the full support of the colonial British government. In 1769, Winthrop and influential friends of Harvard's scientific undertakings, for example, James Bowdoin, John Hancock, and Benjamin Franklin, were no longer on the same political side as the governor and other crown appointees in Massachusetts. So here's a little brief reminder of what was happening politically between these two transits. In 1764, the English Parliament, looking to offset the debt brought on by the French and Indian War, and hoping to defray the cost of running the colonies, increased taxes and placed restrictions on colonial trade. Restrictions included the Sugar Act and the Currency Act. In response, Boston merchants organized a boycott of British luxury goods in August. The political situation worsened in March 1765 with the passage of the Stamp Act. This was the first tax ever imposed by English Parliament directly on its American colonies. Under this act, Americans had to pay tax directly to England rather than to their local legislative bodies. All printed materials, newspapers, pamphlets, broadsheets, legal documents, invoices, licenses, almanacs, even dice and playing cards were taxed. Revenues from the Stamp Act were to offset the cost of the British military in North America. And to add insult to injury, Parliament also passed what was known as the Quartering Act, which required the colonists to house and feed the British troops. So we're funding the troops with taxes, and we're supposed to support them with housing and food. Well, the Americans weren't too happy about this, and they fought back, asserting that the new taxes were unconstitutional. In July, an underground organization, the Sons of Liberty, began a campaign of intimidation and violence, which ultimately forced all British stamp agents to resign and disrupted American trade with the English. And by December, over 200 Boston merchants were boycotting English goods. You have to remember that such English goods include all these scientific instruments. None of these could be made in the colonies. We didn't have the facilities. So all those things were imported from London. In 1766, Benjamin Franklin warned Parliament of a possible rebellion in America if the British military enforced the Stamp Act. Now, because of strong resistance, George III actually decided to repeal the act, but he signed the Declaratory Act, which basically said that the British government had supreme power over the colonies and could tax and legislate as it wished. It was kind of, okay, we'll repeal the Stamp Act, but we are still in charge here. Now, the repeal of the Stamp Act resulted in a relaxation of the boycott on imported English goods. But the boycott was reinstated in Boston in 1767 after Parliament passed the Townshend Revenue Acts. These acts imposed new taxes on imported paper, tea, glass, lead, paint, and other items, and established an American Board of Customs Commissioners headquartered in Boston to act as an enforcer. So now we're up to 1768, and the temperature is definitely rising in Boston. In February, Samuel Adams, that famous brewer, but also a clerk of the Massachusetts House of Representatives and a former student of John Winthrop, organized opposition to the Townshend Acts by means of a circular letter sent from the Massachusetts House to the legislative assemblies of other sister colonies. The response from England was quick. In April, the Secretary of State for the Colonies, Lord Hillsborough, ordered the Royal Governor of Massachusetts to dissolve the General Court if it did not revoke this circular letter. The General Court refused, standing behind Sam Adams and others who had written it, and it was duly dissolved in July by Governor Bernard. In the interim, the Romney, a British warship armed with 50 cannons, had sailed into Boston Harbor in order to back up the Royal Customs Commissioners who were being harassed. Short-handed, the captain of the Romney began to impress Boston seamen to serve on the ship. That means they go out into like a public space, they just like throw a lasso around a bunch of able-bodied men and haul them off to the ship to become members of the crew. Well, this was a very bad idea. Soon after, a customs agent forcibly detained on board the Liberty, that's the name of a ship, a sloop, in fact, owned by John Hancock. And while the agent was detained, wine was unloaded illegally. Here you see John Hancock. I don't have a picture of his boat. Boston's chief customs collector, Joseph Harrison, and he's a name to remember here, decided to usurp his royal authority and make an example of Hancock and charge him with smuggling. On June 10th, Harrison and the Comptroller of Customs seized Hancock's ship and, adding insult to injury, had the Romney tow it away from the wharf. An angry mob gathered and violence ensued. Harrison, his son, and the Comptroller were brutally beaten up. The Sons of Liberty stepped in to calm the mob, but dispersing rioters smashed all the windows of Harrison's home and the Comptroller's homes and those of the Inspector General of Customs for good measure. They also torched a fine sailboat belonging to Harrison. The customs officers and their families were terrified. Their houses are being broken down, windows smashed, things, lit ablaze, they're being beaten up. And they fled to a fortified harbor island and called for intervention by British forces. And here you see Paul Revere's engraving of these warships of the British landing in Boston in October 1768 in response. The Boston boycott of British trade goods continued through the summer and fall. And at a town meeting in September, Bostonians were urged to arm themselves. At the end of September, the British warships, as shown here, as I said, sailed into Boston Harbor, and in October, 2 different regiments set up camp in Boston to keep the order. Now, there were other challenges, too, to organize an expedition for June 1769 that Winthrop faced. In 1764, smallpox appeared in Boston, and the General Court of Massachusetts took refuge in Cambridge, commandeering Harvard Hall for their meetings. And here you see Harvard Hall on the right, and this little cupola had been the observatory for the college. They would take their telescopes up there. And this is what is now really Massachusetts Avenue. This building, Massachusetts Hall, still survives and is still there. But Harvard Hall, in 1764, with the General Court meeting there, the General Court was negligent and left embers in a fireplace unattended when they finished for the day. And on the night of January 24th, during a snowstorm, Harvard Hall burned to the ground. And with it went the college library, its natural history specimens, and its scientific apparatus, all up in flames, a total loss. Among the items lost were the instruments Winthrop had used to observe the transit of Venus in 1761, with the exception of the Martin reflecting telescope and the Tompion clock, which Winthrop had in his house because he made astronomical observations from his home. So those things were out of the building and preserved. Indeed, they survive to this day. Now, these losses were severe, but friends of the college came to his aid. James Bowdoin gave generously from his pocket. Edward Holyoke's son, Edward Augustus Holyoke, gave things. But the most important help came from Benjamin Franklin. Here we have Mr. Franklin with a page of from the archives at Harvard. And Franklin wrote to John Winthrop, he said, "I shall think of the affair of your unfortunate college and try if I can be of any service in procuring some assistance toward restoring your library and apparatus." In October, the Pennsylvania Assembly appointed Franklin to serve as their agent in London, and he embarked soon after. He was there on a colony business, basically to tell the Penn family and other priors that if they kept up this business of taxation without representation, pretty soon they're going to have a real rebellion on their hands. But once in town, Franklin then handpicked apparatus from London's finest instrument makers and had these shipped over to Harvard. Remarkably, the cargo was permitted to enter the port of Boston in 1765, 66, 67, 68, 69, despite the boycott of English goods. Indeed, Franklin and Winthrop seem to have had no trouble rationalizing the importation of English scientific apparatus or the payment of the customs duties, even though they supported the embargo in general. This equipment was just seen as too important to get tied up in these politics. Now, in the midst of these tensions, Franklin forwarded to Winthrop a pamphlet published in 1768 by Neville Maskelyne, the Astronomer Royal, containing instructions relative to the observation of the ensuing transit of the planet Venus. Franklin addressed Winthrop as the only astronomer he knew in North America with the experience, skill, and gumption to observe the next transit on June 3rd, 1769. So here's how he butters him up. He says, Mr. Maskelyne wishes much that some of the governments in North America would send an astronomer to Lake Superior to observe this transit. I know no one of them likely to have a spirit for such an undertaking, unless it be the Massachusetts, or that have a person and instruments suitable. If your health and strength were sufficient for such an expedition, I should be glad to hear you had undertaken it. Possibly you may have an elect, that means a student that is capable. The fitting you out to observe the former transit was a public act for the benefit of science that did your province great honor. Winthrop took the bait. He knew that Lake Superior was the closest place to New England where the full transit could be witnessed. Only half would be visible in Boston. His own health, though, was not sufficiently good to make the arduous journey. But he had a student, a recent Harvard tutor, Thomas Danforth, who he thought could undertake it. The problem was that the assembly that had funded his expedition in 1761 did not exist when he received Franklin's letter of July 1768. As I mentioned, it had been dissolved by the royal governor on orders from London for its treasonous support of Samuel Adams' circular letter. So once again, Winthrop wrote to James Bowdoin, a member of the Council of the Province of Massachusetts Bay, to solicit his help in getting the project funded. He knew that Bowdoin would support the mission on its scientific merits, but he also gave him reasons that might appeal to members of a legislative assembly or military body. And I won't go into the details, but suffice it to say that, these reasons involve finding the latitude and longitude of forts along the way, surveying variations of the compass, and so on. That would be useful for mapping the inner frontier. Winthrop even ventured to suggest who might sponsor such an expedition. Guess who? The beleaguered royal governor, Francis Bernard. Or General Thomas Gage, Commander-in-Chief of all British forces in North America. The very same individual had just sent all these troops to keep the order in Boston. Winthrop writes, I suppose there is no doubt but that a convoy of stores will be sent up to the western ports early in the spring. And if our observers might be allowed to go under the convoy, with the general's order to the commanders of the several ports and vessels on the lakes to be aiding and assisting, the thing might be accomplished without any great expense. And our services would be so useful to the ministry. Well, it was cheeky, to say the least, for Winthrop or Bowdoin to ask General Gage or Governor Bernard for help in 1769. In politics, it was known that Winthrop sided with Samuel Adams. He was a patriot, and he sided with the Sons of Liberty in the 1760s. And he would be a leading actor in the politics of the colony in the 1770s. Bowdoin's position was seen as so subversive that when re-elected to the council in 1769, the governor refused to let him take his seat. He was better kept as a troublemaker out of council, on the sidelines. But Bowdoin approached General Gage anyway, and the governor. He wrote Gage first, writing to him at his headquarters in New York, and enclosing Winthrop's letter. Gage surprisingly responded politely and offered much advice. Letters to post commander, wilderness guides, but no money. When Bowdoin learned that Gage would not fund the expedition, he turned to Governor Bernard and the council. In the meantime, Winthrop was busy planning who would go and what apparatus they would take. Now in this, he was quite stingy in what he would lend from Harvard College and audacious in where he thought to make up the losses. He itemized the instruments in a letter to Bowdoin written in February 1770. The instruments necessary are, first, a good clock. I suppose he will readily be allowed to take that which I carried to Newfoundland. This is Winthrop saying this in his letter. Now that would be the Trompian clock, which Winthrop had replaced with a state-of-art regulator made by John Ellicott, which had a temperature-compensated pendulum. The new clock was valued at more than 35 pounds, and you see it on the right. And on the left is the old Trompian clock. Second on the list was, and Winthrop writes, a good quadrant, an astronomical one if it to be had. Otherwise, a Hadley's quadrant might serve. I have heard that Mr. Harrison, this is Joseph Harrison, the collector, has got an astronomical one which he might probably be willing to lend upon such an occasion. If this should fail, a Hadley's quadrant may easily be got. Now, after the fire with Franklin's help, Harvard had acquired an excellent astronomical quadrant by Jeremiah Sisson in London in 1765, and you see it here. He had also, it was valued at close to Winthrop's annual salary, 59 pounds. And he was apparently not going to let it travel into the remote territory. The use of a Hadley's quadrant and placing an astronomical one does make sense at this period, when Winthrop was reticent to lend the 15-inch brass quadrant made by Benjamin Martin and presented by Ezekiel Goldthwait in 1764. Instead, Winthrop thought that Joseph Harrison, collector of His Majesty's customs in Boston, might be prevailed upon to lend his own personal astronomical quadrant. Now, Harrison in the 1750s had supervised the fabrication of a quadrant by Benjamin King of Newport, Rhode Island, and had used it to run the dividing line between Rhode Island and Massachusetts. See, everyone wears many hats in these days. You could be, collector of the customs duties, and yet the surveyor running the, divisions between the colonies. The quadrant was actually now the property of Rhode Island and would be borrowed by Benjamin West in Providence in 1769 to observe the transit of Venus there. But Harrison owned another quadrant of 3 feet and a half radius with telescopic sights mounted on a grand pedestal with a curious apparatus of wheelwork to adjust its motions. And it had belonged to the celebrated Edmund Halley. Now, it was this instrument that Winthrop set his sights on. But recall that Harrison was the principal figure involved in the episode on the Sloop Liberty 6 months earlier. And after he and his property had been battered and attacked, he had been forced to seek refuge on the harbor island and called upon General Gage for protection from the likes of Winthrop and his friends. Third on Winthrop's list was a good reflecting telescope. And he writes, okay, third, a good reflecting telescope. I suppose one may be borrowed and lost it. I should think some gentleman who may own one would not be averse to lending it. It would be best to have also as good a refracting telescope as can be got, in order to accommodate 2 observers, both of the transit and of Jupiter's satellites, for ascertaining the longitude. There is one belonging to the college of 8 feet length, which no doubt may be had, but if a longer one could be procured, it would be better. Soon after the college was birched, Mr. Edmund Quincy Jr. offered to sell one 12 feet in length, as I remember. If this could be had, or another of about that length, especially in a sliding tube for the convenience of carriage, like a draw tube. Most of these early refractive telescopes don't collapse, don't telescope, if you will. If one could be had with a sliding tube, it would be even better. Well, so writes Winthrop. Now, Winthrop was no more generous in lending the Martin reflector he took to Newfoundland, or the 1-foot short reflector with object-glass micrometer that he had gotten with Franklin's help, or the 4-foot achromatic telescope by Darwin that he acquired also with Franklin's help in 1765. It's safe to say he also had no intention of lending the expedition a barometer, a thermometer, a variation compass that he went on to recommend, and so forth. Also here you see some other instruments that Harvard had. This is a 4-foot Gregorian reflector by James Short that he had for the transit. A 2-foot Gregorian with another object-glass micrometer, and this is the 1-foot. These are all in hand. He's not offering them to go up to Lake Superior. At this time, he's also beginning to doubt the ability of his student, Danforth, to carry out the enterprise and return everything back safely to Cambridge. But he starts to set a date for Danforth to leave only 2 weeks later. He still has none of his gear in hand. So, how is he going to round up all this stuff? So meanwhile, Winthrop is hoarding his all-good apparatus in Cambridge, and he's pondering where to find the replacements. Bowdoin meets with disappointment in Boston. The governor and council, they liked the idea of this research trip, but they found themselves unauthorized to finance it because the general court was dissolved. Legally, they could not act. Bowdoin tried once more to interest General Gage in paying for the trip, but he countered with the suggestion that a public subscription could be used to raise the money. At this time, Danforth becomes ill, and the expedition is abandoned for want of sufficient time as well as money. Now, as disappointment for an expedition descends on Cambridge, Winthrop consoled himself with the happy thought that he could himself at least observe part of the transit with all his new toys provided by Benjamin Franklin and friends in London. So on June 3rd, he records in his diary, quote, "Fine weather for the transit of Venus," and interestingly, this is the only time in his diary he mentions any event aside from the weather. And his observations, then, goes on to make, are meticulously done. In fact, they're much better than those he had made in 1761. After the transit, he reported his results to the Royal Society, noting, quote, "Our apparatus having been wholly destroyed by fire about 5 years ago, we have since procured a new set of astronomical instruments made by some of the most eminent hands in London. A clock by Mr. Ellicott, with a pendulum of his invention, having the bob supported by levers. An astronomical quadrant of 2 feet radius made by Mr. Sisson, and an equal altitude instrument by Mr. Bird, each having 3 horizontal wires in the telescope. A reflecting telescope of 4-foot focus, another of 2 and another of 1 foot, fitted with an object-glass micrometer of 21.5 feet focus, all 3 made by the late Mr. James Short." Winthrop was sensible that his apparatus was as fine as any to be had overseas, for he had communications from the Astronomer Royal, Neville Maskelyne, and Benjamin Franklin on how all the other expeditions were being outfitted. Indeed, after much delay, Franklin had only just been able to forward the 4-foot reflector from James Short's workshop and the equal altitude instrument from John Bird's, because demands on the shop were so great for instruments to go on transit expeditions around the globe. All the instruments Winthrop used to observe the transit of 1769 survive today. So in conclusion, let me draw your attention to this remarkable grand orrery made by Joseph Pope of Boston between 1776 and 1786. Operated by gears and crank, it demonstrates revolutions of the planets and their satellites out to Saturn. It has a beehive dome representing the sphere of fixed stars and a 12-sided skirt whose glass windows are painted with the signs of the zodiac. Between the windows are 12 cast bronze figures representing 3 individuals. The figures, we believe, are cast by Paul Revere, incidentally. The first figure is Isaac Newton, shown literally on a pedestal, inscribed with his system of the world. Next to Newton is Benjamin Franklin, holding a lightning rod, which looks more like a pitchfork. But the lightning rod was Franklin's invention, and he was America's foremost scientist at the time. And James Bowdoin, who, at the time of the fabrication of this instrument, was the governor of the new Commonwealth of Massachusetts. Now, the cosmic frame appears to rest on their shoulders. And I hope my story has shown that in colonial Boston, astronomy was supported by both scientific intellect and the state, just as the iconography of this instrument suggests. But more particular to the story of Winthrop measuring the parallax of Venus, it seems so appropriate for Newton, Franklin, and Bowdoin to be shown demarcating the boundaries of the solar system. Through science, money, and politics, they made it possible for Winthrop to do his part in determining the dimensions of the planetary system. Thank you.